or 18 C and D. A particle moves along a straight line, so its velocity at time t seconds is given by v of t equals 4 sine of t cosine squared of t. When t equals 0, the displacement s of the particle from a fixed origin is 5 meters. Find an expression for s in terms of t. So we're given the velocity function, so we're going to find the integral of the velocity function to find our position function. So you can see I set that up here. I have my integral. I let u be the inside function. Cosine is being squared, so it's inside of another function. So if u is cosine, then du is negative sine of t. We have a sine of t, dt. That matches, but we don't have the negative. So I put a negative on the outside, I took out the 4, and then replaced dt with du. So now I'm just integrating u squared. Integral of u squared is u cubed divided by 3. So I get negative 4 over 3 u cubed plus c. Last step, just substitute our u back in. And now we're going to use the given information that when t equals 0, the distance is 5. So I'm going to plug in 0 for t and set it equal to 5. Then I get the cosine of 0 is 1. So I'm going to add 4/3 to both sides. When I do that, I get c equals 19/3. So for part A, the position function or the displacement function is negative 4/3 cosine of t plus 19 over 3. Part B, find an expression for the acceleration of the particle in terms of t. We're given the velocity function, so the acceleration function is going to be the derivative of the velocity function. You can see that we're multiplying two functions together, so to find the derivative, we're going to need to use the product rule. First times the derivative of the second plus the second times the derivative of the first. So let me rewrite so we have 4 sine t cosine squared of t. So I have the first times the derivative of the second. The derivative of the second will involve the chain rule. So I have 2 cosine times the derivative of cosine, which is negative sine, plus the second function times the derivative of the first. When we simplify this, we get negative 8 sine squared cosine t plus 4 cosine cubed t. Find the acceleration, velocity, and speed when time equals 6. So for part C, we need to find s of 6, v of 6, and a of 6. Negative 4/3 cosine cubed of 6 plus 19 over 3. Okay, I'm just going to grab my calculator, make sure I am in radians. For the position, I'm getting 5.15. For the velocity, I'm getting negative 0.03. This would be meters per second. And acceleration, I'm getting 2.94 meters per second squared. So reading the position function, it is, after 6 seconds, it is 5.15 meters from the fixed starting point, from the fixed origin, I mean. The velocity is negative, meaning it is traveling to the left after 6 seconds. And the acceleration is positive, so it's going left, but increasing, which tells us it is slowing, it's slowing down. It's slowing down. Different signs. All right. Determine whether it is speeding up or slowing down. Oh, we just answered that. So D, it's slowing down. Find the displacement of the particle and the distance traveled over the interval 0 to 6. Okay, so to do this, we are going to find the integral of the velocity function from 0 to 6. This will give us the displacement. Oops. So we already substitute, or no, we didn't, because that, okay. So I'm going to do -4/3 cosine of 6 squared. If I plug in 0 for cosine, I get 1. And so this is going to be -4/3. So I get 0.104 for the displacement. To find the total distance traveled, I need to figure out where it's changing directions, because I'm going to need to break it up the integral. So I need to figure out when is the velocity equal to 0. So the velocity is going to be equal to 0 when sine of t equals 0 and when cosine squared of t equals 0. Sine is equal to 0 at pi over 2, 3 pi over 2, cosine equals 0 at, oh, I'm wrong. These are for cosine equals 0. Sorry, sine equals 0 at pi, at 0, at 2 pi. And 2 pi is actually going to be bigger than 6, so we don't need to worry about that one. But we do need to worry about all 3 of these changing points. So we're going to have 0 to pi over 2, pi over 2 to pi, and pi to 3 pi over 2. And we are going to make a sine diagram to figure out when it's going right and left. And we know, and this is going to go to 6. So I'm just going to type in my velocity function. Where did it go? And substitute numbers into your velocity function. I'm just using the table feature on my graphing calculator. So I'm going to plug in 0.5, I get positive. If I plug in 3, I get positive. negative, and here plug in 2. No, not 2. Sorry, that's 1.5 times pi. Plug in 5, and I get negative. So it looks like there's only one changing point. So that makes this a little bit easier. I should have graphed the function first. So 0 to pi and pi to 6. Oh, I don't know why I put this one up here. Pi to 6, 0 to pi. So there's only one changing point, and one of these is going to need to be negative. So I'm going to graph the function to figure out, ooh, my windows need to be adjusted. Oh, I could tell right here that it's negative. So this is the one I want to change the sign on. Okay, so I already have my function, negative 4/3 cosine of pi cubed minus negative 4/3 cosine cubed of 0. And so I'm subtracting negative 2.5 from 2.67. And I get 5.17. Total distance traveled and displacement.